welcome everybody to another webinar from Chip Foundry. In this webinar, we're going to be covering updates to OpenLane-2, and also known as LibreLane. We're joined today by some guest speakers. Mohammed Gabr, who maintains, many of you may know, he's the maintainer for OpenLane-2 and now what is known as LibreLane. He's going to go through the latest and greatest updates and also kind of walk through an example of how you implement a project using OpenLane-2 or LibreLane for Caravelle. And then also we're going to be covering questions and answers that you have in terms of anything that related to kind of related to this, related to the topics we're covering. We encourage you, if you do have a question, to use the Q&A facility on Zoom. You'll find a button, should be a button on your menu bar at the bottom that has Q&A where you can post questions, and we'll be periodically stopping to review those and answer some of those live, as well as asynchronously. So we do have a team of panelists on. So in addition to myself, we have Mohammed Shalan, who's joined us, who many of you may know. He's as well as Mohammed Qasim and Marwan Abbas from the Chip Foundry team. All right, I think I covered all the logistics. So without further ado, let me turn it over to Mohammed.
Thanks, Jeff. So hi, everyone. I'm Mohammed Gabr. You may know me as the maintainer of OpenLane and OpenLane-2, previously at eFabless. Now, how do I lower my hand? I pressed that button by accident.
It'll go away.
All right. So now I'm a member of the FOSSi Foundation, where I maintain LibreLane, which is the continuation of OpenLane-2, of the OpenLane-2 project that I started at Fabless. So yeah, I'm very grateful to Chip Foundry for the opportunity to do this webinar. I'm hoping that I can show the community what we've been working on and what our path is going forward. Let's start with a little background. Now, I'm assuming you've all at least heard of OpenLane if you've joined this webinar, but if not, OpenLane was an RTL-to-GDS 2 flow by eFabless Corporation in 2020. It was designed to solve the problem of basically when Google released the Skywater PDK, we had the first full free and open source PDK, but there was no flow to target this PDK with, right? So we had a number of design goals, which is basically, first, it should be fully free and open source, right? It should be batteries included and easily configurable. So we didn't want you to go and compile your own tools. We needed all the tools to be included. And we'd ideally like you to configure the entire flow with just one tickle file. OpenLane has even conservatively, been a very great success. We've had hundreds of designs on the OpenMPW shuttles, many more designs on the Chip Ignite shuttles, and it has reached very good widespread adoption. Now, the thing is, while OpenLane was revolutionary, it did have a lot of limitations for the time. Now, it was developed on a very strict deadline, as I'm sure you're aware. It was, we took a lot of architectural shortcuts. Running parts of the flow, which which is useful, as I'll demonstrate later, is extremely buggy because we did not encapsulate the state of OpenLane in a thorough manner. There was no standard way of reporting data about the design, so we created a metrics file, but basically this file is it doesn't handle all tools equally and is just not standard. And it's difficult to add custom steps to the flow to integrate other tools. And, to top it all off, the whole infrastructure was written in Tickle, which, while it's a great tool interface language, it is not great for maintaining a code base that you need to scale. So, back at eFabless, we endeavored to rewrite OpenLane. So LibreLane, as I call it now, is started at eFabless as OpenLane-2, which is a ground-up rewrite of OpenLane. So we thought about OpenLane not just as a flow, but as an infrastructure with which people can make their own flows and customize, either by customizing their, or customizing the default flow, or by just creating their own flows from scratch. It is still backwards compatible with OpenLane 1. So basically, the same configuration files, and whether in JSON or Tickle, should still work with LibreLane. And it's a fully customizable Python-based flow infrastructure. And coming with being written in Python, we do have some benefits. So for example, if you follow this QR code here, you can actually just run the entirety of LibreLane in your browser on Google Colab and inspect the design as it is progressing. So we had a number of key technical design goals while working on LibreLane. So first is we needed to retain the simplicity of OpenLane. Now, unlike deploying your own flow or some other flows, basically OpenLane's signature is that it just works out of the box with just one or two configuration files, right? And I like to believe we've retained that because you still just need the one file and it still works out of the box. We needed to offer robust packaging. So again, just like OpenLane, it's not just build scripts. We need something to use container. We need something that can replicate the environment in various places, not just using Docker, but also natively. And finally, modularity and API access. So we do have a fairly simple object-oriented architecture, and while we do still support the OpenLane configuration files, as I've mentioned, you can very easily implement your own flows, which was actually key to us because that's the reason we rewrote OpenLane in the first place. So this is the architecture that we came up with. So basically, the beating heart of LibreLane is the state module, right? So the state module basically is an explicit encapsulation of the current status of the design. So basically, it's an immutable dictionary from say that says, for example, okay, so this design has a netlist, and the netlist is at this file path, right? So the idea is we can capture the state of the design, which allows us to rewind to this state at any point in the flow, which is very, very powerful. The next module that we have is the step module. Now, a step is, you can think of a step as an implementation step in ASIC. But what it is technically in LibreLane is that it's a transformation on the state object. So it takes in one state and returns a new state, right? So for example, if you pass the netlist state to the floor plan step, it returns a new state that also has a def file because, you've done floor planning now, right? The third module is the flow module, which encapsulates aggregations of steps for ease of configuration and ease of execution. So basically, it allows you to put steps serially or even do things like run multiple steps in parallel. And basically, it's just a helpful abstraction on top of steps. Last but definitely not least is the configuration module. Now, in OpenLane, we've had this issue where people would misspell variables and then the flow would not warn them about that or would not, and they wouldn't realize until, it's already been 3 hours and it's done routing. So the configuration module actually performs validation of all the variables used to configure the flows and steps, including things like type checking, making sure you didn't use a float instead of an int or otherwise, um, making sure arrays are actual arrays, etc. All of this was key to us because we wanted the user experience to be as good and as tightly integrated as possible. These four modules can be accessed via the LibreLane Python API, which in turn can be accessed in one of three ways. So first of all, you can just type Python, you just type import LibreLane, and then you can just use the LibreLane object-oriented interface. This also extends to Jupyter Notebooks, which, if you've come from the machine learning or the data science space, you realize are these very popular tools where you can run the flow, and then you can run flows for things like models and visualize the results as you go. And we've been so happy to bring that to the EDA space with LibreLane. And finally, as usual, you just have the command line interface to LibreLane, which I will demonstrate shortly. So, everybody following so far? All right. So let's move on to using the classic flow. So the LibreLane classic flow is the default flow of LibreLane, and it is basically a re-implementation of OpenLane using the Python API. So just like because LibreLane is an infrastructure, we need a way to be compatible with OpenLane. But of course, it comes with a bevy of enhancements. So basically, we've improved the handling of macros. So macros isn't just listing extra lefts. You actually have a macros object that you can list each macro and its various views. And the power pins, you can even just declare an RTL with an if def because the flow is just so much more robust. We have parallelized STA, so including nine corner extraction and analysis. So every STA step is run across all 9 corners. Uh, and then basically, so we're talking about all 3 PVT corners and all 3 interconnect corners. So 3 by 3 is 9, and we do the STA in parallel, and we also do the parasitics extraction parallel, which will save a lot of time for larger designs. We also introduced additional DRC with K-layout, so it's not just Magic that's our sole sign-off tool, even though it is still the primary sign-off tool, but we're also redundant because there are some errors that K-layout is better at catching. There is basic system Verilog and VHDL support. So there you can add you can use VHDL files instead of Verilog if that is your if you so desire, um, which is useful because there is a lot of IP that is VHDL only, and translating that to Verilog first is something of a chore. And finally, better tool warning capture. So basically, LibreLane, unlike OpenLane, it actually goes into the tool logs and captures every single warning and error emitted by the tools. So if a warning or error happens in, say, OpenRoad or Magic, LibreLane will make sure that you see it, and it will not be silently ignored. This is huge to us because, in sometimes in when you're using OpenLane 1, Magic would just encounter something and you wouldn't know about it. Now, sometimes it just, it's an error that you can ignore, but sometimes it isn't, right? So running the default flow is fairly simple. You can just type LibreLane dash dash Dockerized, or dash dash Dockerized if you want to use Docker. We have 2 methods of installation. So one is Nix and the other is Docker. Docker is just like OpenLane. You can just pass dash dash Dockerized and pass the configuration file, and it would run it in Docker. But if you're using Nix, what you can also do, which is new, is that you can use some GUI flows. For example, open in K-layout, which would open the design in K-layout for you, which I will demonstrate shortly. So now all of this is pretty much just like OpenLane, but what's new here is basically if you understand how states work, you can unlock a whole new world of things to do. So this was popular with our PNR engineers back at eFabless because it allowed them to investigate multiple branching paths from the same state. So let's say we've got state N, which is basically just a uh, def layout of the design. I put netlist here by accident. I apologize. So this is a def layout by the design. Now, I want you to remember that each step consumes a state and generates a new state. Now, what I didn't mention is that I also save each state in a JSON file, which means very easy exploration even from CI. So for example, you could take this same state, right, design.def, state n, and then pass it to global placement once with a single configuration variable, and then pass it once again with a different configuration variable and compare the results. Right. So so what I'm going to do here is that I'm just going to run the flow, right? And then I'm going to save the latest state in a bash variable, right? And then what I can do is I can run you can run the rest of the flow twice, once with the target density set to 50, and once with the target density set to 55, right? And I can even do this in parallel using two terminal windows, or I can do this in parallel as well using using the Python API, because, both are, everything is independent is immutable. So you can just run things in parallel as you desire. So now I'd like to demonstrate some practical use of LibreLane with the Caravelle user project. Now, I'm happy to report that LibreLane is silicon proven with Caravelle user project. Technically, OpenLane-2 was, but same project. The design, so we've tested an AES accelerator design, and it worked. It worked great. We tested it in a temperature chamber and everything. And the design continues to be part of this continuous integration for LibreLane to ensure it continues to work properly. And it's so simple to use. It requires either Docker or Nix, and I'm just going to demonstrate that right now. So here I clone Caravelle user project to my computer, right? So this is just Chip Foundry Caravelle user project, the main branch. Now, as usual, we recommend that you type. I don't, not the inspector. So as usual, you type make setup. Now I already did this because it takes some time. Now to update LibreLane, you can just type make LibreLane or make OpenLane. We included both for your convenience. So I'll just type make OpenLane, and what it'll do is that it'll install OpenLane using the Python package manager pip. So it will just install LibreLane, and you're done. Now, again, for your convenience, it's a drop-in replacement for OpenLane, so you can just type make user project example. And what it will do is basically it will use the Docker container for LibreLane and start running your design through it, right? But you've already seen that. That's just basically OpenLane. The real exciting stuff happens if you have Nix installed. So if you have Nix installed, so if you type make LibreLane Nix, right? So what it's going to do is actually activate what's known as the LibreLane Nix environment. Now this basically allows you to do what I showed you earlier. So let's say, for example, I want to run the user project example with two different density characteristics. First of all, I'm just going to run the flow. So the way you run the flow is you type LibreLane and then path to the configuration file. So LibreLane, so that's going to be OpenLane user project example. Oh, I'm already in OpenLane. Apologies. So LibreLane, OpenLane user project example, and then config.json, right? Now, I'm going to give it a run tag, which is base run, and I'm going to run it just up until before global placement, which is going to be openrow.custom.io placement, right? So I'm going to press enter, right? And then, oh, what it is, so you'll notice I entered the step name incorrectly. So OpenLane's robust error management will tell us there's no such thing as OpenRoad custom IO placement. Did you mean ODB.custom IO placement? Which I did. So I actually wasn't planning to demo that, but it came up during practice and I found that to be pretty cool. So yeah, I'm just going to do that, and I'm going to press enter, and you'll see that the flow will run up until the exact point I told it to stop, right? So it's going to generate the PDN. It's going to do everything just until the second iteration of global placement. So, right. So yeah, you'll see every step after that has been skipped, right? So that's perfect. Now what we want to do is use the step that we generated here, the state, pardon, we generated here, and explore parallel, parallel timelines from there. So what I'm going to do is what I'm going to do now is I'm going to first, I need to put the state in a variable. So I'm just going to say base state equals to open, force of habit, LibreLane.state latest. So I'm just going to pass it the run directories, which is user OpenLane, user project example, runs, and base run, right? So this is going to put the base state in a variable for me. It's just a JSON file, right? So what I can do now is that I can, okay, so LibreLane, I'm just going to use the config file again, and then I'm going to give it run tag density 0, and then run tag density 0, and then from openroad.global placement. And you'll see here, you can just start and stop it anywhere in the flow. Now, the key thing I'm going to do here is I'm going to pass another variable called with initial state, right? And then I'm going to pass it the base state we saved earlier. And then I can just, this is another convenience that we have, but you can basically override any variable from the terminal. I believe this was also an OpenLane, but you can just say PL target density %, and I'm just going to set that at 50, right? And that's just going to run in its own, and that's going to run here, but I'm just going to copy this, right? Because I do want to explore multiple things. And you just let that run, right? Now, while that's running, I'm also going to do a parallel exploration. So once again, make LibreLane nix. And then I'm going to call this run density _1. Oh, and I put that as, and then I'm going to make that 55 instead of 50, right? But, oh, right, because I forgot to, apologies. I forgot to copy the base state. Sorry about that. And then I'm going to run this again. And you'll see here, I'm running the same design twice, right? Once with one variable and once with another variable. And then I can just let them both finish. Now, now obviously this takes a while, but so I'm just going to interrupt this. But what you can also do that's pretty interesting is, as I've mentioned, if you have Nix installed, so I'm just going to interrupt this run. But you see here, if I can specify the same run tag, so I'm going to get rid of with initial state, so it uses the latest state instead. And then I can just type flow open in OpenRoad. Right? Now what that's going to do is that it's going to open the OpenRoad GUI for me with the design, and then I'm free to inspect it as I see fit. So this is a tiny design, so there's not much going on, but you can see here, I'm just gonna I need to see the instances, so let's go ahead and do that. Where are the instances? Well, you got the idea. Basically, you can see the layers here, the rows, the instances, whatnot. So that's the GUI capabilities that you can use here. And all of this is running natively on, you can run natively on either Mac OS or Linux. So yeah, so basically it hadn't, so basically this is the run tag density 0 with the flow open and OpenRoad, and density 1 is still going. I'm just going to do the same thing here. So yeah, same thing. The placement should be slightly different, but I'm not sure if something's misconfigured with my right. So you'll see here, I have filler cells all over the place and then some buffers, and this is a pretty tiny design. It's just a counter, but you can just inspect the design as you see fit. Right. So that's what you can do with LibreLane. You can run this natively. Of course, if you don't want to do any of this, you can just still type make and use Docker. But this is really, really powerful. And our, back at eFabless, our PNR engineers were able to basically just test multiple runs of the design at the same time without having to rerun costly synthesis or otherwise. So, finally, I'd like to talk a little bit about the community and support for LibreLane. So for adoption, obviously, it was adopted pretty thoroughly internally back at eFabless. We'd used it for some of the most advanced chips ever taped out with an open source, with open source utilities. right? We also, it was also pretty quickly adopted by Tiny Tapeout. Thank you. Shout outs to Matt Venn for that. Uh, we've also had some success in the academic space. So there was the Purdue University Stars program. Now, what they did is something pretty cool, which is we worked on an OpenLane-2 plugin that actually added support for Synopsys tools, and they were able to use that to teach students chip design over the summer using a mix of both open source and closed source tools, which is unprecedented. And now Chip Foundry, which basically LibreLane is the primary flow for the Caravelle user project now, which thank you. So we do obviously support multiple PDKs. So we do support Sky 130, which, as you know, is the primary PDK for the Chip Foundry shuttles. We also support a number of other PDKs, so GF180 MCU and the IHP Open PDK in an upcoming version. For the community, I'm going to answer that one live because I'm going to answer that one live. So basically, for the community, there's the FOSSi chat. So this is a community for FOSS Silicon and FOSS Silicon development. It is hosted and administered by the FOSSi Foundation, of which also, Chip Foundry has a community there that they will link you to, and anybody can sign up. It's free. And for the documentation, you can just go to librelane.rtfd.io. We have installation guides for both Nix and Docker, and a full migration guide from OpenLane to LibreLane, and a full flow steps and variables documentation. So basically, if you want to know the IDs of the steps, so you've seen me write openroad.whatever and odb.whatever, all of this is listed here in the documentation. And that's it. Thank you so much for having me for this, Chip Foundry. I really appreciate it.
But thank you. It's really great. That's a really great presentation. Thank you so much for walking through that and going through it. And just to build a little bit on, kind of some of the history. At eFabless, we had run about 20 shuttles of each of those containing up to 40 projects, and I would say, for some of those shuttles, they were like 100% OpenLane. At the time, it was OpenLane 1. And then obviously as we got into kind of chip creating the commercial ones, I'd say at least probably 50-60% of them, were running OpenLane for those projects and completing, successful silicon. So there's a lot of history behind the design flow, a lot of tape outs that have occurred. And that's just speaking to kind of the experience at eFabless. I know it's being used out and maybe being used as well another outside of that. So really, really great, and look forward to continuing to the advances and the improvements that you walk through to kind of
Thank
take
you.
advantage of those and enable those for customers who are trying to do tape outs on shuttles.
Thank you. I just like to just mention a couple things before I stop here. Just huge shout outs to Professor Shalon and Kareem, who both worked with me on this at eFabless. Basically, this project wouldn't be anywhere near what it is without them. Thanks to Philip Wagner and Leo Moser from the FOSSi Foundation, who were able to give this project a new home and give us the infrastructure that we need to deploy such a huge project. Yeah, so I just, sorry, I would feel bad if I didn't mention the contributions of
Yeah,
these individuals. And of
absolutely.
course, thank you for your leadership on the project back at eFabless. I really appreciate it.
Well, thank you. Awesome. So really appreciate it. Also, we're gonna switch over to Q&A here in a second. Just before I do that, I just want to invite I don't know if Mohammed Qassem or Mohammed Shalan, you'd like to comment or add anything before we go into question Q&A. Sorry if I caught you by surprise. All right. All right. Well, go ahead. Let's just go ahead and switch into questions. So we got a few questions that are posted into the Q&A. So we'll go over some of the open ones as well as maybe go back to some of the ones that were answered offline.
Just for Efaz in chat, don't raise your hand. Just ask in the Q&A panel.
Yeah. if you just post your question in the Q&A, that's the best. We're gonna
Mhm.
be again, this overall the whole webinar is recorded, and we're going to be posting that and making that available to everyone who registered, along with the materials that Mohammed presented. So you'll get a copy of that, but we will be eventually making it available through our YouTube channel as well. So we're not going to be doing any live interaction because of that, just to kind of help protect people who don't want to be public. Okay, so we have a question about how easy is it to implement a custom plugin, let's say DFT. So probably two
But
interesting topics on that.
so funny you should ask, Eleftherios. I'm working on that exactly right now. That's my thesis. So yeah, I am working on a DFT plugin for LibreLane. It's still in the works, so I'm still cooking it, but it's going to be quite it's going to be quite cool when it's done. And obviously, I know you, I recognize you from the fault issues and whatnot. And if you'd like to help out with that, just please reach out. I'd really appreciate it.
Excellent. All right, next question. Hey, I've just started to learn OpenLane. I want to run synthesis, PNR, GDS. Can you help me? I want to run Caravelle Flow, which is available on Git. So yeah, I think I would suggest reaching out to us at info at chipfoundry.com, and we can definitely get you pointed to the resources that are available in learning. And then Don also, like, so when you get these slides, there's a number of links that he presented in terms of documentation, tutorials. I think the Jupyter notebooks too, Don, are probably a really good starting point for someone trying to learn.
Yeah. The Jupyter Notebook is a good place to try to learn, but if you want to work with Caravelle specifically, you can just clone the Caravelle user project and get started. I
Yeah.
mean, the documentation is still identical. You just need to install Docker and type make setup, and then you can just go,
Yeah.
right?
I mean, you can literally repeat what Mohammed just walked through, like in a few
Yeah,
minutes, and actually run the flow, and then you can kind of see what it's doing, and then start to explore from there.
right.
All right.
So,
Next one.
uh,
Go ahead. You're gonna say
so
something?
next one I'm interested in answering is from Nicholas. Sorry, I shouldn't mention names. I forgot about that. So, basically, somebody's asking how to enable new tools and flows. Well, it's pretty simple. So we have a tutorial here on writing custom steps. It's all in the documentation. So we have a tool on writing custom steps and custom flows. Uh, Essentially, a step is basically something that just you take in a state object, you subclass it. So if you have any experience with object-oriented programming, you just subclass it, and then you can just run any process you would like, and then as long as you return a result, right? So we did do that here. I hadn't had the chance to migrate this from eFabless yet, but there's also an OpenLane plugin example. So basically, this will show you how to make a plugin for OpenLane-2 that includes both a custom step and a custom flow. I need to update this for LibreLane, so I will do that. Please stay in touch, and I will post that I will post that as soon as basically I've done the requisite work. Thank you for your interest.
Super. Looking for a completely free chip making for my students. Okay, well, there in the past there had been some programs that provided some sponsored fabrication. I mean, definitely you can use all the tools that we're showing. Students can use and try and build chips with that are ready for fabrication. In terms of actually getting the cost of fabrication covered, that requires some sort of a sponsorship or some program in order to be able to do that. There are a number of things like that that are being discussed, but I don't have anything I can point to right now in terms of free fabrication, at least not through Chip Foundry. But we will keep. I would definitely encourage you to kind of, if you haven't already registered on our site for our email, sign up on that. I would definitely recommend doing that. And if as things continue to progress, we'll definitely be posting everyone there, as well as through the messaging platforms.
Right.
Okay,
So
good.
yeah.
Next one.
Another question I'm interested in asking is I'm interested in answering is how what is the difference between the LibreLane capable update of Caravelle user project? What are the differences to the older A Fabulous Caravelle OpenLane 2 beta? So it is building on that work. So uh, uh, basically what I've done is that I've updated it to a newer version of LibreLane that is just has more bug fixes and features and just cleaned it up a bit. But other than that, it is that version. So
Great. Can you maybe speak to someone's asking about Docker, what the purpose of it is, and maybe it'd be worth just kind of covering that as well as Nix, and because
of
and for
course.
people who aren't familiar with Nix, maybe a little bit of a background on what Nix is and
Of
kind of
course. So Docker, so the purpose of Docker specifically is to create a way that packages all of the tools required for LibreLane without having to account for your specific Linux distribution or your specific version of macOS uh, or whatnot. What Docker is essentially like a small little environment with everything you need to make chips installed in it, right? Now, we also allow you to install well, not allow you, enable you to install the tools using a package manager called Nix. Now, Nix is also OS independent, and it also supports Mac OS, but Docker is the most widespread option for this in the industry and is especially useful for things like cloud deployment and whatnot, right? So we do offer both Docker containers and an installation using a package manager named Nix. Both are available in the documentation. In hindsight, I should have added a slide or two about that, but
and then Nix runs
apologies.
in some sort of a virtual environment, or like I saw when you used Nix multiple times to when you were doing like the two different runs. Is that
Right, yes. So what Nix does is that it's still native, so it's still running on your computer, but what it does is that it creates a shell, right? A shell with the right environment variables and everything set up. So what you can do is that you can go enter this shell and have everything ready for you, and the moment you exit this shell, it's not contaminating your environment, right?
okay,
So that's the key benefit of Nix here.
great?
And what this also allows you to, so actually, sorry, but that's also allows you to do something that you couldn't previously, you can't usually do, which is you can switch between various versions of LibreLane. So you can have both an old version that you're using to repeat a previous tape out, and have a new version and both running side by side, right?
Great.
Both running side by side.
Okay. Let's see. So I think we answered that. We have, is there a description of the reports? Timing available? Do I need to dig into the individual tools documentation?
So basically, no, you do need to dig into the individual tools documentation. What we do as LibreLane is that we try to so what we do is we process the reports and extract them into what's called a metrics file, right? And the metrics file, so basically includes things like, the worst slack, the number, the total wire length, just things just quantities you prefer to know about the design. So actually, I can show you the metrics file right here. So I'm going here to, so I guess I want to use less OpenLane.
You're not
Fine, let me
sharing.
share. Yeah, I forgot to press the share button. Thanks. So Caravelle user proj, uh, less OpenLane user proj example runs. So let's do density 0. And then the latest step is, I suppose, ODB remove running obstructions. So let's go in there and state out.json. So you'll see here in the state out file, basically, we do capture a lot of metrics about the design. So you'll see here is that we have, the worst hold the worst hold, the worst setup, and whatnot. Design instance count, we extract whatever we can about the design, which is useful for if you're trying to do any kind of analysis or machine learning on the design. This is based on a standard called Metrics 2.1 that was, I believe, submitted to the IEEE OpenShip design group. We do adhere to it pretty strictly, and yeah, you can use this file or you can read the reports submitted by the tools. Both are valid options.
Super. Also reminds me that if you have topics, so we are actively working on building out the knowledge base, trying to cover common questions or issues or things that you'd like to understand, get more clarity on. So if you have any of those type of requests, please reach out to us and let us know kind of some of the questions or things you'd like to see covered. Also, we're going to be scheduling additional webinars going forward. So any topics you've interest or questions or things you'd like us to explore or demonstrate would be also helpful and valuable for providing feedback to us on that. You can obviously provide it here, or you can also provide it through reaching out to us like at info@chipfoundry.io. Yeah, so I think that, I appreciate any input you have on that as we go forward. Okay, next one. I've encountered some DRC errors when trying to harden the user project wrapper with the Sky 130 SRAM macros in LibreLane. Okay, so I think that's relatively, I think we had another question on this as well.
Yeah, so this is a pretty common issue. So what happens is that SRAM uses has special foundry rules that other designs are not allowed to do. We are actively working on a workaround for that. But what you can do for now is just you can there is a variable called error on magic DRC, I believe. You can just set that to false. So I'm gonna post that in chat.
Okay, and then you should reach out to us. We are just revising or refreshing kind of the flow using the SRAM macros that we're now making available through Chip Foundry, the same ones that we actually were used by eFabless previously. But we are kind of continuing to review and iron out, making sure that those flows work correctly, both with the previous version of OpenLane 1 as well as LibreLane going forward. All right.
So
Where is the foundry located, which makes chips for you? That's Skywater Technologies. They're located in Minnesota, Bloomington, specifically.
Mhm.
And that is, of course, the foundry behind the open source PDK, this what we call the Sky 130 open source PDK.
Yep.
Awesome.
Yeah.
Next one, video tutorials on getting started. More to come on that. We have some. You can go back and look at eFabless, and there's a bunch of videos that eFabless posted that are still available. But we're going to be updating and refreshing some of those as well.
Yep. Also, you're watching one, so
yeah, and then this one will get posted as well.
yep.
As well. Right, exactly.
Rootless feedback with only slightly modified container arguments. We are using LibreLane/OpenLane in a rootless podman container. This also works great. Yeah, because I do too. So I'm glad it worked for you as well.
Super. All right, there was a number of other. That's all our current open ones. There's a number of questions that we answered offline. Trying to think if there's anything worth commenting on any of those. Marwan, is there anything that any of those questions that are worth kind of maybe raising live?
No, I think we covered most of them.
Okay. Very good. So let me go ahead and bring up. Lost my slides. Sorry, give me 1 second.
What is the number of input-output pins the foundry can make? So if you check the Caraville documentation, it will show you how many pins the user project is allowed to have. And are we supporting OpenFrame, Jeff?
Yeah.
Yes. Correct.
Yes. So there is also OpenFrame, which basically is the documentation for Caravelle OpenFrame will also list the number of pins that you have. So we actually do mandate that you use either OpenFrame or Caravelle. So the number of pins is actually immutable.
All right, very good. Any other questions before we wrap up? We covered them. Okay, great. And then
Yep.
just
Yeah.
for your reference, if you're looking for more information, I'm posting a few links here, ways to reach out to us, both email, Discord, and FOSSi chat. You can find
Well,
more information.
there's one last question that's
Okay.
actually important. Yeah.
Sure, let's cover it.
So is Caravan still available?
Yes.
Yep.
So
Yes,
both,
Caravan is still
yeah. So both. So we currently supporting both Caravelle, Caravan, and OpenFrame.
Yeah. Well, okay, that's
All right.
great.
And there is a
So, yeah.
video that we had the previous webinar where we covered a lot of the basics for that solution, and cover some of those questions as well. If you want to check that out, it's available on YouTube under Chip Foundry or Chip Create actually. So there should be a link from that at the if you go to chipfoundry.io, you can find the link to our YouTube channel there. All right, is that good? Is that everything on the questions for now?
That is
All right,
everything.
super.
Yeah, that is everything.
Well, thank you again, Mohammed. Really appreciate it. Thanks everyone.
Thank you for having me. I really appreciate it.
Absolutely. And thanks everyone for joining. Look forward to seeing you on another webinar in the near future. Take care, everyone.
Please feel free to reach out if you need anything. I am in both the FOSSi chat and I'm joining the Discord momentarily. So just ping me and I will try my best to help you with LibreLane or OpenLane.
Great. Thank you. Take care. Bye.
Thank you.
Bye bye.
Bye.